Hello, thank you for watching this video. So in this video, we'll be doing question 9 of May, June 2022, question from mathematics paper 1. And these are cubic functions. So I'm going to read question 9 statement and then answer the questions that follow. So question 9. Sketched below is a graph of f. So here is our graph of f. I've sketched it here. The x-intercepts of f are at 3 and m, where m lies on the x-axis. So they are saying the x-intercepts of our function are at m and 3, right? Where m is on the negative x-axis, right? They are saying k is a y-intercept of f. They are saying k here is the y-intercept of our function f. M and n are turning points of f. M and n are turning points of f. That's it. I don't think I need to explain this. This one is straightforward. 9.1. Show that the equation of f is given by the f of x is equal to this. So they're saying show that the equation of this function is this one here. So what they've given you, they gave you an incomplete skeleton or incomplete version of the equation of this function. So they wanted to show that this equation here, which is incomplete, is this one here. That's what they're asking you to do. So let's go. So we're given this white x-intercept here and 2 of these here, right? So if you are given, if you are given the x-intercepts, you say, okay, f as a function of x is equal to a into x minus x-intercept 1 times x minus x-intercept 2 times x minus x-intercept 3. Right? This is how you find the equation of a cubic function if you are given the x-intercepts. So a here is the coefficient of x cubed of a cubic function. It is the coefficient of x cubed of a cubic function. So we are given that f of x is equal to x cubed plus whatever. So a, the value of a, is a coefficient of x cubed here. Then what is the coefficient of x cubed? The coefficient of x cubed here is 1. So you have your a is equal to 1. That's what you have so far. And you have the x-intercept 1. X-intercept 1 is equal to 3. Right? Now, x-intercept 2 and 3 are the same because they are here. At this point, there is an x code. The x is the turning point and the x-intercept. So, x-intercept 1, x-intercept 2 is equal to x-intercept 3, and that equal to k, where your k is less than 0. So you allow them to be some k, which is a real number there, such that that real number is less than 0 because it's on the negative side of the x-axis. So what do? You say, okay, I'm going to substitute my information here. So I have that f as a function of x is equal to a. What is a? A is 1. X minus x-intercept 1. What is x-intercept 1? X-intercept 1 is 3. X minus x-intercept 2. X-intercept 2 is the same as x-intercept 3, which is what? Which is equal to k. Then x minus x-intercept 3, which is also k, because x-intercept 1 and x-intercept 2 are the same, because that point is a turning point and the x-intercept. So let's simplify this. Oh, we don't have to. Also, from this you know that you are given one point there, k, which have coordinates 0 and minus 3. So what this tells you is that if you substitute 0 here, 0 here, and 0 there, where for x is equal to 0, then the corresponding y value will be minus 3, which means you can substitute your x, your y is minus 3 there, is equal to 1 into 0 minus 3, 0 minus k, 0 minus k. Right? Then you simplify this. This becomes negative 3 is equal to simplify this is minus 3k squared, right? Which is, let's transpose the negative 3k squared to this side. So you have 3k squared minus k, or minus 3, sorry, is equal to 0. So from here you solve the value of k. So this is a quadratic equation, right? You know you use the quadratic formula of factorizing. So let's factorize it. So what we have 3k squared minus 3 is equal to what? Is equal to 0, right? Let's take out the common factor, 3. So you're left with k minus 1, k squared minus 1, right? 0 is equal to 3 into k plus 1, k minus 1. I'm factorizing this. But if you can't factorize, you can use a quadratic formula from here. Good. Then, which means your k is equal to 1, or k is equal to minus 1. So, which ones of these k values do we take? Our k is on this side of the x-axis, so k should be negative. So it's less than 0. So this is the one that we want, not this one. So now that we have our correct k value, we substitute our k value where? Here. And in fact, substitute our value here, and then multiply this out. And see if it won't be the same as this, as what we're trying to prove. If it comes out the same, then we're done. So what we say, okay, f as a function of x is equal to what? Is equal to 1 into x minus 3 then here what do you have? You have x minus k, your k is minus 1, and x minus k again, which is minus 1. So I've substituted here. Then your f as a function of x is equal to 1 into x minus 3, x plus 1, x plus 1. So f as a function of x is equal to, multiply this out. So you have x minus 3 into this, multiply this part, this one out, becomes x squared plus 2, x plus 1. And this multiply that, so f as a function of x is equal to, this times that is x cubed, this times that, 2x squared, this times that plus x. That's where we are. We're done multiplying with this one. So multiply with this one. This times that is minus 3x squared. This times that is minus 6x. Negative 3 times 1 is minus 3. Then you collect the like terms, group them together. So your f as a function of x is equal to, there's nothing with a cubed, there's only this one. So take it down as it is. You look again. So this one and this one look the same. So you have minus x cubed squared. Add these two. This one and that one look the same. So you have minus 5x minus 9. So f of x comes out to be this, which is the same as that one. So we have shown that the equation f is equal to that. And you're done. Let's go to the next question. 9.2. 9.2. Calculate the coordinates of n. What is n? They wanted to calculate the coordinates of n. What is n? N is our turning point here, right? If you draw a tangent on a turning point, it will always be horizontal. For example, if you look at the x-axis here, there is a tangent to this turning point here. So, which means if you want to draw a tangent to this point, it will be horizontal. It will be a horizontal tangent like this. A tangent to a turning point is always horizontal. As a result, its gradient is 0. The gradient of a horizontal line has a gradient of 0. If you draw another tangent there, its gradient at that point is 0. Which we know the gradient, since our tangent has the gradient of 0, we know at this point the gradient is 0. We know at that point the gradient this point that the gradient at n is equal to 0. Whatever the coordinates of n are, the gradient at n is equal to 0. Good. Okay. So how is this going to help us? So we know from our calculus classes that a derivative of a cubic function or a derivative of a function gives us a gradient at a point. So if you find f prime at x, this gives you the gradient at a point. The derivative of a function gives you a gradient at a point. So in our case, what do we say? We say we know our gradient is 0 at that point. Let's find the derivative of f. So what is f? F as a function of x is equal to x cubed minus x squared minus 5x minus 3. The gradient of this is f, the derivative of f is f prime is equal to 3x squared minus 2x minus 5. This is what? This is the derivative of f, which is our function. So this derivative gives us a gradient at a point, which means if we substitute a point here, the answer that we get will be the gradient at that point on our function f. For example, we have x, which is 3 here. If we can find f prime at 3, the answer of this is what the gradient is here at 3. Which means if you draw a tangent here at 3, the tangent will have this gradient that will be the answer here. Let me repeat this again. So, if you find f prime at 3, which means on this thing of yours, you say, okay, 3 into 3 squared minus 2 into 3 minus 5. The answer of this is the gradient on our function f at x is equal to 3. So, let me find whatever the answer is there. So, the answer of this is equal to what? Is equal to 16. This is an example. So what this tells us is that if we draw a tangent, if we can draw a tangent here at x equal to 3, we know that that tangent will have a gradient of what? Of 16. Because the gradient at 3 is equal to 16. So the gradient here is equal to 16. Which is, if you're drawing you want to find the equation of a tangent at x equal to 3, that tangent will have the gradient of 16. That is what a derivative of a function gives you. It gives you a gradient at a point. I'm going to clean this because this was just an example. Okay, so what do? We say, okay, since the derivative give us a gradient at a point, we know at our point n that the gradient is 0. So we know what this part is. The gradient is what? Is 0. So we want to find the x value which gives us the gradient of 0. We know at our point that our gradient is what? Is 0. So now what you want to find is this x value that gives us the gradient of 0. What do? We substitute 0 here and solve this equation. So we have 3x squared minus 2x minus 5 is equal to 0. This 0 here is that of the gradient. This gives you the gradient. So you want to find what are those x values that give me the gradient of 0. Then x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Right? Want to find our x value. X is equal to negative. What is b? B is minus 2 plus or minus the square root of minus 2 all squared minus 4 into a, which is what? Which is 3. C, what is your c? Is minus 5. All over 2a. What is your a? Your a is 3. So x is equal to, oh, your x is equal to. Let's punch that on our calculator and see what to find. Negative 2 plus the square root of negative 2 squared minus 4 into a, which is 3, c, which is minus 5, over 2 into 3. We get our x is equal to 5 over 3. What is our second x value? Is equal to minus 1. So, what did they ask us to find? They wanted the coordinates of n. So, n, the x coordinate of n is up here. So it is positive. So between these two, which one is it? It's going to be this one. So we throw this one away because we know this one, this x equal to minus 1, it belongs to m there. The reason we got it is also because at that point, the gradient is also equal to 0. So what you did here, you were asking for a point or points where your gradient is equal to 0. It gave you both points. It's both these local maximums. Local maximum and the local minimum. That's what this thing did for you. It gave you all the points where you have the gradient of 0, which those points are turning points. This is what this thing did. So which means you know your x coordinate there is equal to 5 over 3. And it makes sense because on the positive side of the x-axis. What we need now, we need the y coordinate. To find the corresponding y value, if you have an x value, substitute on the original equation. What was the original equation? The original equation was f of x is equal to x cubed minus x squared minus 5x minus 3, right? This one, what is this? This is an equation, original equation of our function. But now we want to find the corresponding y value of this x value here. So f at 5 over 3 is equal to 5 over 3 cubed minus 5 over 3 squared minus 5 into 5 over 3 minus 3. So f at 5 over 3 is equal to, punch that in your calculator and see what you get. So you have 5 over 3 cubed minus 5 over 3 squared minus 5 into 5 over 3 minus 3. So your answer is minus 256 over 27. This is the corresponding y values. Therefore, the coordinate of n is 5 over 3 and minus 256 over 27. These are coordinates of n. That's how you do this. Straightforward. Start by deriving. Once you find the derivative gives you a gradient at a point, but you know at our point the gradient is 0. Then substitute the gradient and then solve for x. Once you find x, find the corresponding y value. Done. So, this is 9.3.1. Let's go. They are asking, for which values of x will f of x be less than 0? Right? They are asking, what are the values of x will our graph be negative? What are the values of x will our graph be negative? Where is our graph negative? That's the first question you should ask yourself. Our graph is negative where it is below. Where is below this line? Our graph is negative. All the points that are below, along this line, our graph is 0, right? Everything below this, our graph is negative. So let's shade it. Our graph is negative. At here, it's 0 here. After this point, it's negative here. It's negative because it's below, even here. It's below x-axis. But here, it's 0 here. So You can't say it's negative at this point. It's positive. It's 0 here. But then, after this point, which is -1, right? You got the coordinate space, -1. So after this point, it's negative again. At that point, it's not negative, it's 0. It's here in here. This point is 0 as well. Because it's on the x-axis. This point, 0, and that point is 0. So it's negative for all x values that are less than 3, right? But remove that 1 there. So our function will be below the x-axis if x is for all values, for all these values of x. Let me highlight the values of x as well. Because if these are your y values, right? The corresponding x values are these ones here. Because this will not go inside this circle. Because this circle means it represents the x is equal to 3. So these are all your x values. Then we won't touch this again, and then to all these ones. So this goes to negative infinity. This one goes to positive infinity. So what are those values of x? Are all the x values that are less than 3. Your x value should be less than 3. But your x must not be equal to, your value should exclude -1. So your x must not be equal to -1. Right? Or someone else would say x is an element, should be in the interval from negative infinity to before this point plus this point here, which means x is an element of negative infinity to -1 union -1 to 3. So these are your x values. The last one I didn't like very much. So your function will be negative if x is less than 3. For all x values less than 3, except for that one. Because that point we know our function is 0, not negative. Which is the same as saying x is an element of negative infinity to 1 union that interval. That's all. This is it. So now we go to 9.3.2. For which values of x will f be increasing? They're asking what are the values of x will our function be increasing? So what does it mean for a function to be increasing? It's going up, which is its gradient is positive. Should have a positive gradient. Should have a what? Positive gradient. That's what they're saying. Should have a positive gradient. You can see it's increasing here. It's increasing there as well. So what are those values of x? Our function is increasing here in this area. It's increasing if you go up here. If you go to the, look, so to see if your function is increasing, you must increase your x and see how your function behaves. Look, here's what I'm going to do. If I increase my x values, my y value is also increasing. So look here, I'm increasing the x value, my function is decreasing. Continue increasing, it increases again. So you find your function where it's increasing by increasing the x value and see how the y value behave. So my function is increasing here. It's decreasing here, increasing here again. So what are those values of x? Those values of x must be less than -1. Right? It will increase. For x is less than -1, which is this interval here. Our function is increasing. For x, x is less than -1. Or, what does it increase again? It increases after, we said this was 5/3. For x is greater than 5/3, it increases again. Or for x is greater than 5/3. Because this was the corresponding x value. Or someone else can write it in intervals. So someone else will say, is the interval, 5/3 greater than 5/3? Or 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 5/3 after this point going this way. All those x values that side, right? All the x values that side to infinity, and all the values from negative infinity to this point. So we want to say the interval x an element of negative infinity to minus 1, right? Union 5/3 to positive infinity. This is it. We're done with this question. Let's go to the next one. That would be 9.3.3. Let's label it. Okay. For which values of x will f be concave up? So they're asking what are the values of x will our function be concave up? What does it mean for a function to be concave up? It means I want the function to be concave up, which means I want the function have a shape like this. A shape like this. You can see maybe somewhere here it started having this shape. So what was happening? From somewhere in this area, our function started having this U-shaped shape. Started having this U-shaped shape like this one. Before this area, you can see our graph was concave down. It was like this. Our graph was concave down. It was like this before this area. So somewhere here, this graph changed from being concave down to being concave up. So this is concave down. Yeah? And this one here is concave up. This one. So they were asking what values of x will this graph be concave up, which should have a shape like this. So in this area here that I've circled, our graph changed from being concave down, right, to being concave up. So the point where that change happened, where our graph changes from being concave up to being concave down, is called the point of inflection, right? This area here, somewhere this point, some point here, where the concavity changed, our graph changed from being concave down to being concave up, is called the point of inflection. So in order for you to be able to see where it is concave up or concave down, you will use the point of inflection where the concavity changes as a reference point to use it to compare the x values. So what you need to find the point of inflection. When you have the point of inflection, then you will be able to tell where it is concave up and where it is concave down. So we need to find the point of inflection. The point of inflection is the point where our concavity changes from being concave down to being concave up, in this case. So let's go and find that x-coordinate. So the x-coordinate of the point of inflection, where the concavity change. To find it, you say the x turning point 1 plus x turning point 2 over 2, which means it's going to be minus 1 plus 5 over 3 all over 2. So the x-coordinate of the x-coordinate of a point of inflection is called the answer of that. Let's find what is the answer. So the answer is 1 over 3. So what they're saying is that our point of inflection is not on the side, it's somewhere this side. It's 1 over 3, our point of inflection. Somewhere here, our point of inflection. Not here. Which our concavity changes somewhere here. Which means it was concave down all the way, and then here it's concave up. So this point 1 over 3 is where the concavity changes. Which means at this point it's concave down. After this point, it changes concavity. It changes concavity here. It's not concave up, it's not concave down. After this point, it becomes concave up. Right? So, it's concave up after this point for all x values that are greater than 1 over 3. Because you can see it's concave up here, where the corresponding x value is all the values after 1 over 3 going to the side. So, it's concave up for x is greater than 1 over 3. Or 1 will say x is an element of 1 over 3 to positive infinity. That's where our function is concave up. It's concave up after 1 over 3, which is the point of inflection. And I'm done with 9.3.3. We go to 9.3. We'll go to 9.4. So I'm going to clean the board. I think I'm also going to clean this and redraw it again, because I think we will need it. A cleaner version of it would be nice to have. So let's clean the board and then we'll go back. Okay, so I've drawn this thing here so that it looks a bit nicer. And now I'm going to answer to read the question and try to answer it, because we will need it. So they are saying 9.4. Determine the maximum vertical distance between f and its derivative on the interval between -1 and 1. Okay, so they are saying find the maximum distance, maximum vertical distance between the graph of f and its derivative, which is the gradient function, in the interval between -1 and 0. So they are saying, suppose that you have, okay, so you know that here your x coordinate of the turning point is -1, right? And here your x coordinate of the turning point is 5 over 3, right? So if you draw a gradient function, which is, if you derive this, you get a gradient function. A gradient function is the derivative of this. F prime, because f prime gives you the gradient at a point. That's why I'm calling it a gradient function. Is equal to 3x squared minus 2x minus 5. So this is the gradient function. So if you plot the gradient function here, if you equate it to 0, then what you will get its x-intercepts, right? But its x-intercepts are the x-coordinate of the turning point, because you will equate it to 0, which is you find it's a point where your gradients are 0. Right? We did this one. We're going to find the coordinates of the turning point. So now, if you plot this, you will need the x-intercepts, right? So if you equate it to 0, this is a gradient function. These are the points where your gradient is equal to 0. Then, these points are these two. So if you draw it, your gradient function, it will look like this. It will intersect here. It will be something like this. This one is a gradient function, f prime. So, what they want you to find, they want you to find the maximum vertical distance between your gradient your function and its derivative in the gradient function. So they want you to find the biggest distance between these two. It can be here, or it can be here, and it can be here, can be there. This is the vertical distance. Can be like this. So we don't know which one is the biggest, right? We don't know which one will be the biggest, but they want the biggest distance between these two. So you are optimizing here. You want the maximum distance, the biggest distance. So in order to find the vertical distance, let's say here, you know that the coordinates of this point is -2 and -8, right? Then here, then somewhere here, directly above this one, you get that your coordinates here are -3, -2, and 16. Right? If you want the vertical distance, this is the vertical distance between them. What are you going to say? You're going to say the the highest height, the distance between these two coordinates will be equal to 16 minus what? Minus 8. So your distance would be equal to 16 plus 8, which is equal to 24. Right? So this will be the distance between these two. So if you have a point here and another point vertically above it, to find the vertical distance, you subtract the y values, the x values don't change. So the distance between these two could be that minus this, which is equal to 24 units. That's how you find a vertical distance. So now we need to do the same thing here. We need to apply the same logic. Right? So I'm going to clean this because this was just an example. So now we know what is y for this one here. We know what y is for this one. The big y. Your f, it is f, right? Which is equal to x cubed minus x squared minus 5x minus 3. That is your y value where? Up there. And your y value at the bottom is on the gradient function, which is on the derivative function. F prime and x is equal to 3x squared minus 2x minus 5. So these are your y values. This one y value is here. The other y value is up there. So now, if you want the distance between them, you will subtract the bigger y value with the smaller y value, which is what you did here. Right? So what we're going to do, we'll say, okay, the distance between the function, which is between f and f prime, will be equal to what? F of x minus f prime at x. This is the distance between. This is the distance between f and its derivative. So what is that? Distance between f and f prime will be equal to f. What is f? It's x cubed minus x squared minus 5x minus 3. This is your f, this one, right? Minus your f of x. What is your f of x? It's 3x squared minus 2x minus 5. So d is distance between f and this derivative would be equal to what? Simplify this. X cubed minus x squared minus 5x minus 3 minus 3x squared plus 2x, this time that, plus 5. Then we group the like terms. Distance between f and this gradient function is equal to, this one is on its own here. So take it down as it is. The squares is this one and that one there. So we add them, this and that is minus 4x squared. The x's, we have this one here, then that one there. So it's minus 3x. This and that is plus 2. I hope I added these things correctly. So it's negative, positive, positive. Then say this one is on its own, we took it down. We added this and that, minus 4x, right? X squared. This and that, they added up to what? They added up to minus 3x, and then these two added up to 2. This is the distance between them. But now we want to find the maximum distance, right? So what we're going to do, we'll derive our distance. So d prime of f and f prime, we're deriving this thing now, is equal to 3x squared, right? Minus 8x, derive that, minus 3. Then what you do, equate it to 0 and solve for your x. So this will give you your x value where you get your maximum distance. Solving this will give you the maximum value, the x value where you find the maximum distance. So what do we do? X is equal to negative b plus or minus square root of what? B squared minus 4ac all over 2a. So x is equal to negative b, 8 plus or minus square root of what? 8 all squared minus 4 into a into c all over 2 into 3. So let's find our x values then. Punch that in a calculator. What do you get? So it's negative into negative 8 plus the square root of negative 8 squared minus 4 into a, which is 3, to c, which is minus 3 over 2 into 3. The first x value comes out to be 3, right? And the other one is x is equal to minus 1 over 3. So these are the x values that we will get. Which one will make sense? They told us that x was less than 0, greater than minus 1, right? So this one, minus 1 over 3 is less than 0, greater than minus 1. So this is our x value that we want, not this one. So this x value is the x value that gives us the maximum distance, right? Then now, we want the maximum vertical distance. We want the distance. To get that distance, you take this thing x value of yours and go substitute it on that distance, on that equation that gives you the distance between the two formulas, the two functions. So you can take this and say, okay, distance between f and f prime is equal to, take that, you do say minus 1 over 3 cubed minus 4 minus 1 over 3 squared minus 3 minus 1 over 3 plus 2. So the answer that you get here will be the distance between f and this derivative. What is that? Let's go. Say, okay, minus 1 over 3 cubed minus 4 minus 1 over 3 squared minus 3 to minus 1 over 3 plus 2. What do you get? You get that the distance between the two things is equal to 68 over 27 units, which is equal to 2.52. That is the distance between these two functions. This will be the biggest distance here between these two. If you subtract all of them, this will be the biggest. And we're done with this question. I hope it makes sense and correct. So yeah.